Lesson 97, graphing linear inequalities. If you remember, a line has an equation y equals mx plus b. If we're doing inequalities, just replace the equal sign with a less than or equal to or greater than equal to, and it becomes an inequality. So when we are given a problem that says, is this point a solution to the inequality, all you do is plug in the values for x and y and see if it works. So is 3 negative 2 a solution to y is less than or equal to 2x minus 8? So we just plug in our y, negative 2, is that less than or equal to 2 times 3 minus 8? 2 times 3 is 6, minus 8 is a negative 2. Since they are equal to each other, then yes, this point, 3, negative 2, is a solution to that linear inequality. So if we are asked to graph an inequality, let's do one like this. Example 2. Graph y is less than or equal to 1/2 x plus 2. So the first step is you graph the line y equals 1/2 x plus 2. So you pretend like it's equals. If you had a less than sign, it would be dotted or dotted line or dashed. So if it's greater than or less than, it's a dotted line. If you have greater than or equal to or less than or equal to, you're going to graph a solid line. So since our example here is a less than or equal to, we are going to do a solid line. So I go up 2, my y-intercept is a 2. The slope is 1/2, so from that point I go up 1 and over 2, and I make a solid line. And y is less than or equal to that. So where is y getting smaller? So here's my y-axis, it's getting smaller below the line. So we shade below the line. Some people say, hey, plug in a point. So if I plug in 0, 0 doesn't work. 0 plus 2 is 2, and if y is 0, 0 is less than 2, it works, so you shade that side. If you plug in a point and it doesn't work, you shade the other side of the line. Here's an example that I want to graph that does not have an or equal to. So graph y is greater than 3. So number 1, I'm going to graph the line y equals 3, and I'm going to make it dotted. So y equals 3 is a horizontal line at y equals 3, and I'm looking at greater than. So y gets bigger above the line, but just to be sure, I'm going to plug in the point 0, 0. When x is 0, y is 0. Since 0 is not greater than 3, I graph the other side of this dotted line, and it's going to be above the line. And let's do another couple of examples. This one we want to graph 5 minus 2y is less than or equal to 3x. So before we can graph this, we need to solve for y. Okay, so I'm going to subtract 5 from 3x. I get negative 2y is less than or equal to 3x minus 5. And then I'm going to divide by a negative 2. Because I'm dividing by a negative, I need to flip the sign and make it greater than or equal to. So I have y is greater than or equal to negative 3 halves x plus 5 halves. Here we have this negative divided by negative. It goes to a plus sign. So my y-intercept is 5 halves, which is 2.5. My slope is negative 3 halves, so I'm going to go down 3, 1, 2, 3, and over 2. So that point is 2, negative 1/2. And let's see, it's a solid line, so it's solid. Going to connect the dots, make it solid. And where does y get bigger? It's above the line. Y is getting bigger up here, so graph this. And if I wasn't sure, I could plug in 0, 0. and I would get 0 is greater than or equal to 5/2, which is not true. So I graphed the other side, and that's the end of the lesson.